Hey guys, welcome back. So in this video I would like to show you a few things that I received last month, things that I need for different projects, and I would like to talk about two of these projects that are going to come. And I thought this might be interesting to make kind of a mailbag video and show you guys what I typically buy for projects and things that are really useful, like this over here. And this is either a buck or a boost converter module. I can't really remember. We will take a look at that and a few other things. So for one, I'm currently working on a project that involves PC water cooling. And I already made a water block, this one over here. Now this is not what the video will be about. This is more like a, how could I say that? So this is a water block made from a standard aluminum heatsink 4x4 centimeters and some acrylic and these plastic fittings glued directly into the acrylic. And this I made to get a baseline of what is needed in sense of surface area between the base plate and the water to achieve water cooling. And this I already used in a test setup to cool a CPU, or rather a few different CPUs, and I was really surprised with the result. This is much better than I thought. But the actual water block that I'm going to show you will be not like this one over here, but more like a refined version. So what I needed was, for one, a drill bit to drill G1/4 threads into acrylic, and I bought this from eBay, I think. And this was rather expensive. I mean, €7 for one drill, but I now got it, and this is really nice. And one thing I do when I receive drill bits is apply some oil right away to protect the metal, because if you treat your tools right, then they last really long. So I'm going to apply enough oil, and then I do for all my drill bits, router bits, everything, also for my CNC machine. So this is now pretty good oiled up. That's one thing I needed. And the other thing I needed were some fittings. Now, fittings for PC water cooling, they are rather expensive. Good fittings can cost like €5 a piece. But these over here, these barb fittings, I got 6 pieces for only €8. And these I'm going to use in the actual project about PC water cooling, CPU blocks, making your own ones. This will also be more like a series. I will start with one block design, change variables, flow speed, surface areas, stuff like that, to get a bit more into the actual science behind PC water cooling. And I'm going to use these fittings. They are for 10mm inner diameter tubes. And also there is not really an advantage using anything else beside barb fittings. They just look a bit better. But for my purpose, I'm going to use these. Then there's this one over here, this package, and I haven't opened it yet. This just came, and here are these inside. I already knew that because of the feel of the packaging. And these are high voltage generators. They might be quite interesting to take a look at. And what I think this is it's not an actual like transformer, high voltage transformer, but more like a how's this called, this ladder type, using diodes and capacitors to get high voltage. So it's a high voltage generator, like it's also advertised as. This, I will make an own video about these. Now, I already told you about these modules that I bought some. I don't know if they are buck or boost converters. I will take a look at that in a moment. But first, yeah, throw them around. No, first, let's take a look into this package. There's something on top that will be another future project. This is what I'm currently working on. This is an electronics DC load, and it will be designed for maximum TDP of 480 watts of power. That was what I estimated. I think that I'm not going to achieve this much power with that kind of design, and this is not the final design. This is just what I started. I thought about a few problems, inserted some capacitors, but I still have to take a closer look and actually build one part of it. So this is in here because of the components that I bought. So for example, I bought these over here. These are 5 watt 1 ohm and 5 watt 0.1 ohm load resistors that will be used as shunt for the DC load. Then I got some nice project boxes, and they really surprised me because one of these only cost €2, and you can how was that? Oh yes, like that. So they open like that, and they have a lot of space inside. And this is really interesting if you, for example, want to build a power supply. Then I got a small project box. This is a small box with screws, and I can't really remember why I bought this, but there was a reason. And then the same project box, the big one, is available in a smaller version. Funny part is the smaller version costs the exact same as the bigger version. And this I bought for a specific project that involves a lot of resistors, and I bought quite a few. For example, this 0.6 watt, I think this is a 0.1% resistor, can't remember the value, but essentially I bought resistors from 1 ohms to 10 mega ohms. The high resistances, I think at 100 kilo ohms, are 0.1%, and everything below is 1% accuracy. Reason for that is I want to have a resistance reference, and this will go inside of here. I will have 2 binding posts, the board with the resistors, and switches to switch the individual resistances. It will be something like this over here: resistors, switches, 1 binding post connected to the switches, and the other end of the resistor to the other binding post. Now if I close the switch, I get the set resistance. And then I've also bought some thermistors that are for a project where I try to control fan speed. I bought specific thermistors that are designed to measure temperature. They were a bit more expensive than normal thermistors. Get more resistors, so many resistors. And I've bought these. And these are transistors, the IRL540 NPBF in TO220 package. And they will be used as the power transistors for the DC load. And I chose them because they don't require a high gate voltage to open up. So this will be perfect for design with op amps and low control voltages. And then I got this over here, or these IGBT transistors in TO247 package. And they normally cost €4 a piece, but they were reduced to $1.50, so I just had to buy them. I don't have a reason for them right now, but they might come in handy in the future, so I bought 4 of them right away because they are high power ones. Now let's take a closer look at these IGBTs. These are IRG4PC40F, and they are rated for up to 600 volts, continuous collector current of 94 amps at 25 degrees Celsius, at 100 degrees Celsius, 27 amps continuous. So we can expect a continuous current of 27 amps from these if they are halfway decent cooled. 100 degrees Celsius is what I typically go for. Not the heat, the temperature for the IGBTs in use, but the rating that is over here, just to have a bit of more safety margin I will cool them typically to 65 to 75 degrees Celsius, so they live long enough, but I don't overdo it with cooling. And I will go for the 100 degrees Celsius rating just to be safe. And here's something that is a bit more interesting for me right now, the IRL540s. These are power MOSFETs that are used in switchable power supplies, but I'm going to use them in my DC load project. They have a maximum operating temperature of 175 degrees Celsius. I haven't seen that really often. Pretty interesting. They can be operated at up to 36 amps at 25 degrees Celsius, 26 amps at 100 degrees Celsius, tested with 10 volts. They have a pulse drain current of 120 amps. Wow, that's a whole lot. And a maximum power dissipation of 140 watt. So you have to be careful with that. The 120 amps there, that is yeah. Okay, other than that, nothing too special. Well, one reason I bought them is because they can be driven with a relatively low gate voltage, and I will use in my DC load project a 5-volt reference, not like a dedicated reference IC, more like it's highly likely I'm going to use an LM317 because the reference voltage has to be not that stable, I think. Maybe I'm wrong, I have to test that. And last but not least are these DC modules over here. And as I said, I can't remember if they are buck or boost. MT3608. Is this the IC? It's this small chip over here. Can't see it. B6289D. That was really hard to read. This small chip over here. Guess what? We just tested. Okay, everything is hooked up accordingly. I've got my multimeter in a DC mode, and I'm now going to fill in 12 volts DC. Let's see what happens. Yeah, that's the problem. Okay, 12.8 volts. I'm not 100% sure, so let's adjust the potentiometer. Yeah, that's weird. Okay, let's try another one. Maybe this one is damaged. Okay, and this one over here displays a really low voltage. I think something's wrong. That doesn't feel quite right. And oh, we have a short. Power supply shows 1 amp going through. Okay. Try another one. Let's turn the power supply off first and turn it back on. Again, 12.88 volts. Now it changes. Okay, so no, it does not. Oh, okay, for some reason these pads, they're shitty. No, normally these crocodile clips are totally fine, but with this it doesn't work. So I have to solder some wires to it. Third one not working. So I say that's a fail. Completely useless crap. Let's see the other two. Okay, so 5 modules not working. So I just searched for these, and yes, I bought them from Banggood, and they were advertised with a input voltage of 5 to 24 volts. These are buck converters for up to 2 amps, and there's no way 12 volts would damage these. So we'll contact Banggood customer support. They are really helpful, and see what we can do about that. So I hope you like this kind of video where I show you what I buy and explain to you a few things why I bought them. For example, these load resistors for the DC load project, or these MOSFETs over here. And I explained a few other things like the resistors for my resistance reference project, which it's less likely to be a video because it's not really interesting. It's just soldering resistors. And other things I did not explain, but these are just things that about these high volt generators. I will make a video about them, and these small modules, although none of them are working, and I will contact Banggood customer support. These are just modules that any hobbyist just needs. I mean, not everyone, but most of electronics hobbyists need them for projects. Whatever you use them for. I mean, having an assortment of different buck and boost modules is just beneficial in my opinion. In future videos I will again show you things I buy, and you will get explanations in the sense of this is for this project and this I did not buy for project just because I did it. And I hope this is an interesting video, and if it is, please leave a like, comment down below, and I hope to see you next time. Bye!